Hey everyone, and welcome to TGIK Fridays at 1 p.m. Pacific, live from the Heptio studios here. Hello, how's everybody doing today? Feels good to be back in Seattle. I was in Portland last night and this morning, and I flew in just for TGIK, especially today. So how is everyone doing? I'm in getting stuff pulled up right now. It's good to see folks. Let's see, I'm gonna pull up the chat. We all know this is my favorite part of the week, is saying hi to everyone. All right, so we have Dig Olive saying yeah, Jason. Philip Martin, hello from Paris, good to see you. Lamatti, it's always great to see you. Mateus, good to see you again. Hopefully you can help me out again if I get off in the weeds. Good to be here. We have Heptio, I think that's George, on the Heptio chat. So he's here, as usual, helping out with the HackMD and some of the other things. He'll put his stuff in the chat and explain it to everyone. Marco, good to see you. Ashish says hello from across the lake. I'm assuming you mean Lake Washington, in which case, hello, good to see you. But yeah, welcome. We're going to be talking about the Cluster API today. I'm really excited about this. I spend a lot of time doing public speaking about this type of stuff, and I've this is like sort of a reflection of a lot of work that myself and a lot of people here at Heptio and Google and other places have been working on for quite some time. So getting to actually live demo it and explain it to people finally with like concrete examples is going to be really rad. So I'm super pumped about that. It looks like we had some other folks join us. We have hello from Montreal. Hello, Eric. Steve, good to see you. Happy Friday. Duffy. Whoops, it was Duffy masquerading as Heptio. It was not George. Okay. Well, Duffy, if you want to masquerade as Heptio and share the HackMD, feel free to. Roy, happy Friday, Chris. Jason, good to see you. Jason. Lamatti. This is really great because it's like all of the Cluster API people are in the chat for TGIK today. So it's just like the old gang got back together for TGIK. So that's really exciting. Okay, so let me grab a quick drink, and then I'm gonna get stuff set up, and we'll jump right in. Oh, also, feeling much better since last week. Last week was like crazy. I was sick, but still managed to get in and do it. Still had a lot of fun. Ended up going, I think, like 2 hours or something. But a week of laying around the house and healing really did the job here. So this is like one of my first days back, and I'm really pumped about it. Okay, so without further delay, let's jump into our HackMD, and I can share this too if we don't have a link yet. So let's see, screen plus face. We want this one here. So let's see, how do I want to share this HackMD? So I can come here, and I can go down to my secret window that nobody else sees, and I can paste it in. And there we go. That's me as the Heptio account. If anybody wants to go and join the HackMD and take notes as we go through the episode, feel free to. It's just good old GitHub Markdown on the left and notes for the episode here on the right. Feel free to take notes if there's anything you want to share or ask or think that would be relevant to write down. Feel free to just type them up here on the left side, and they'll show up here on the right side. Let me adjust my screen really quick. There we go. That looks much better. Let's see what Lamatti says. It says, huge thanks to Heptio for managing Kubernetes and CNI available for free. You rock. You're welcome, Lamatti. Happy to help out. Oh, and Chuck's here too. Good to see you, Chuck. It's been like, 10 minutes since we saw each other, so good to see you again. Cool. So we're going to start off. I've got a lot of links in here for Cluster API, and I've got some other This Week in Kubernetes things that are exciting. We've got a little Go demo thing for today. Sometimes I'll do like a Golang, 5-minute learn something in Go. And we'll be doing one of those today. And then we're going to jump into the Cluster API. And I have a feeling today is going to be a lot of me talking about like sort of the design here and looking at a couple of different repositories and then actually running it and checking out logs and seeing what's going on. Sean Smith says, happy Friday, everyone here in Seattle. It is a great Friday here in Seattle. Like, it's really, like, I can look out the window over there, and it's super sunny, and flying in from Portland this morning, I got to see all of the mountains, like literally all of the mountains, and it was really exciting. So yeah, it's a good day here in Seattle. Okay, so let's skip past Cluster API. This is the Cluster API, which more on that later. This is the AWS specific stuff we're going to be looking at today. And let's go right into this week in Kubernetes. So I've only got a couple this week. It's been kind of a quieter week. Suresh says, hey everyone, greetings from Hamburg, and we have somebody from Turkey. Good to see you as well. So this first one here is kubectl sudo, which I just looked at this about an hour ago. I don't know very much about it other than the fact that the name was extremely enticing, so I figured it'd be good to just kind of go through this together. We pulled this off of the R Kubernetes subreddit, and just anytime I see anything that's called like something sudo or people are trying to do something sudo, I get super interested and I want to see what's going on there. Also, while we're on the topic of sudo, I just want to be very clear that I intentionally pronounce it super user do instead of super user do, even though I think technically it's pronounced sudo, but I'm a sudoer. So if you want to drop a +1 for sudo and +2 for sudo, 2 for do, that rhymes, feel free to vote in the chat. I'm just curious what people think and how they pronounce that word. Anyway, let's see what's going on here. This project does not really introduce a kubectl plugin, but a concept of how to provide a sudo-like system for Kubernetes access. It says Kubernetes cluster admins have great power. This means that they make a mistake, they could cause the cluster to become unhealthy or insecure, just like a Linux system. Moving on, a simple kubectl -f on a file, wrongly namespace can end badly. So I think this is the solution here. To reduce the surface or unwanted expected actions, you can reduce the default privileges of a cluster admin. When a cluster admin needs privilege, he or she can switch to the group system's masters or any other user. Okay, so it looks like all this is doing is it's setting up some RBAC rules and roles to help give users a more sudo-like experience with managing their clusters. And this first role, we have this, it's called an impersonator, so I have a feeling this is going to be like our negative check here. And it looks like we create a few other roles. We have cluster admins. We're giving them the cluster role impersonator. And then here we just do a kubectl as. This is a handy little flag if you don't know about this yet. This allows you to run kubectl as a specific user. And you can also run it as a specific group defined in RBAC as well. And I think it just kind of packages this whole RBAC system up and gives it a handy little alias here called kubectl sudo. So this is a fun little program. Something like this is probably a good example to at least learn how to start creating things like RBAC rules and groups and how to start using them, and probably learn a little bit more about RBAC if that's something you're interested in. I don't know if I would enjoy the idea of having sudo on a cluster, but yeah, maybe it could be useful. I don't know. So moving on. Oh, wow. Everybody's voting. I want to see what everybody's voting for. Let's see. We have Justin, who finally made it from Vancouver. We have a ton of +1s. Duffy says, this is just a Raptor for kubectl, as I think. It's neat stuff. I really like this pattern because from the audit side, you get the benefits as well. Okay, so Duffy brings up a good point, which is if you're actually doing an audit on your Kubernetes resources, having a unique group defined for that would give you the ability to go and see which group made which mutations to your cluster. So it gives a little bit of a paper trail for people interacting with their cluster. In the case of somebody actually going in and doing something malicious or goofing something up or providing the wrong namespace or whatever, we can actually go and tie that back to some sort of RBAC configuration. So that's handy. And Lamati says, did you get this working with KTX, Duffy? What is Lamati talking about? Oh, Sean says, interesting, wasn't aware of the as stuff in kubectl. Speaking of KTX, well, we can look at that a little bit later. We're going to be using some of it. But yeah, that's a good way of managing kube configs. One of our engineers here, Amy, tweeted about managing kube configs, and I can do a little demo of how I do it here in a second. But yeah, we're getting off in the weeds. Let's go back to our This Week in Kubernetes. So this next one was exciting because I've been thinking a lot about this, which is a bare metal install of Kubernetes. And yeah, you can actually come to, this actually is a pointer to the subreddit here. Let's see what folks are saying. Lamati, nope, it's Duffy this time. The audit even will show you who the impersonator is. That's good to know. I think Duffy's talking about the sudo tool we just looked at. Okay, so in this example, I think all that we're really doing is we're gluing together a lot of Kubernetes setup for what people would, run on a bare metal type environment with some Ansible scripts and some vagrant-y things, which is a lot of this configuration here. And I think this is just a good example of sort of what it takes to get a basic Kubernetes cluster up and running. To me, this is probably more valuable than anything else, is just having a set of finite steps that sort of highlight what you would need to do, or at least start to think about how you're going to do it. Right here, it looks like we're setting up some networky things, and if we scroll down, here's where we actually install the various components on our system. It looks like we're running a Synaptic-based package manager, so I'm assuming we're running on something like Debian or Ubuntu here, but you can actually see that we are defining some various repositories and adding keys for packages like Kubernetes, just regular Kubernetes, and we're installing Docker, and we're doing some Python-y things as well. And then ultimately down here at the bottom, we get to this kubeadmin little phrase, and you can see that we're installing kubectl and kubeadmin and a few others. So this is a good example of getting it bootstrapped with Ansible, and you can actually go and see how the Kubernetes components in the master and everything look here, and how you would go about configuring it all. But more importantly, what I think this does is it shows how you have to know certain pieces of information about other parts of your system as you bring up a Kubernetes cluster. If you go through here, you're bound to find stuff like take this token and copy it over to this other server, which is where tools like Kops and Kubicorn come in handy, because it sort of does that magic for you. But this is a good resource if you just want to understand what it takes to get Kubernetes up and running. Let's see what folks are saying in the chat here. Sean says, yeah, I just use symlinks to manage kube configs. I was planning on looking to KTX after seeing Amy's tweet and the responses. Sean, yeah, we can do later on, if I forget, remind me. Once we start looking at the Kubernetes clusters that we're bringing up, I can do a quick demo. Actually, you know what? I'm just going to do it now. Why not? So here's my terminal. This is like specifically for you, Sean. So right now, if I do a kgit pods or a kgit po, nothing should happen. And I promise I'll jump back on track here in a second. So this is hanging, nothing's wrong. But if I do a KTX just regular, you can actually see that I have various Kubernetes clusters defined in my kube config. This is actually the Cilium one from a couple of TGI Kates episodes ago. And then I have this Kubernetes admin, which this is very common for kube admin clusters. And then you can see I have our Heptio dev and prod Kubernetes clusters here as well, because I have access to Heptio prod servers. And then MiniCube, which we're going to be using today. And then I just downloaded this tool to run this called Kube Context. This is just a really handy little bash program. And I think to install it, like, it's just like a one-liner. Like, you just paste something in. And I think I've even talked about this before, but it's called this Kube CTX tool here. And there's an example of how to run it. And then I just alias this to KTX. So if we go back to my terminal, you can actually see that alias grep KTX. You can see that I just have kube CTX alias to KTX. And I think Chuck, one of the folks on the call, also has this tool called just KTX, which is confusing. Let's see if we can find it. I wonder if I can type Chuck. Because I alias mine to the same name as his project, which is Heptio Labs here. Heptio Labs KTX, and I think this is sort of does the same thing. It just allows you to manage your kube configs in the same sort of way. So anyway, managing kube configs, it's a thing. It's possible because kubectl itself will actually munge a lot of configuration declaration bits into the same kube config, and then it just has this one-liner that says context that allows you to switch between the different configurations in there. So that's why you can manage multiple clusters, and you can switch between them just by redefining the context field in your kube config YAML. Anyway, back to our, where were we? Nope, already looked at this. Back to our installing Kubernetes bare metal here. So if you want to check this out, feel free to come check it out. It's an example. Looks like it was working for a lot of folks, and it looks like it's a good step-by-step guide for getting Kubernetes up and running in a bare metal data center, which I've been doing a lot of thought about this, and there's been some folks at a publishing company I've been working with who has yet to be named, who is very interested in sort of a cloud-native infrastructure and bare metal-y type of book that somebody might be writing in the future. Anyway, more on that later. Let's see what folks are saying. Ashish says, pro tip for folks dealing with multiple clusters, show context as part of the bash prompt. That will show the cluster you are pointed to. Yes, so that goes back into the editing your bash prompt. A lot of folks like to do that. I personally like to keep my bash profile simple as possible, but that's for my own crazy reasons and the fact that I try to keep things as simple as I can. Sean says, yeah, I generally keep a cluster per file, but have a context per namespace in my kube configs. Seems good. Thanks, Chris. Hearts and smiley faces. All right, let's get back on track here. This last one, I'm going to skip to the bottom here. It's deploying Spark on Kubernetes. This is something that has been, not only is something that me and my girlfriend talk about a lot because she does a lot of work on Spark, but a lot of folks ask about Spark on Kubernetes as well. I'm definitely not a Spark expert, but I am a Kubernetes expert. And at the end of the day, Kubernetes advertises to be able to run any application. So in theory, if you look at Spark as just another application, despite its complexity, it should be possible to actually get a healthy cluster up and running in Kubernetes. And I know we've looked at things like Spark controllers and operators and Spark Helm charts and a couple of others. So this seems to be another attempt at getting Spark up and running in Kubernetes. And the first thing that I noticed when I came and checked out this example here was we are actually building a Java container, and we're using the JDK8. So already a little bit excited / nervous because we're running Java in a container, and we all know that there are some perils with the JVM running inside of a containerized system or inside of a container itself, especially before Java 10. So curious to see how that would all play out. And then it looks like we do some, we're building some Spark Hadoop containers as well. And then we actually have a deployment for the Spark master. And then we scroll down and I think we have a deployment for the Spark service. And then we have Spark workers down here. So this is how we would actually build a distributed Spark system. It's exciting because this actually goes from 0 all the way to getting Spark installed in Kubernetes, and then it goes a step further, and it actually goes and it gives you this this example down here at the bottom running PySpark to actually get you like a Spark query or whatever it would be called up and running, and you can actually go and execute something against Spark, which I think is neat because a lot of folks don't go that extra step. So this is a good sort of round robin approach to just running a simple PySpark command in Spark on Kubernetes. So very exciting. Timmy joined. Hi, Timmy. Howdy, Kris. I'm late. I'm sorry. It's okay, Timmy. Just don't let it happen again. So a Decent says, good evening from Russia. Good evening, everyone. Thanks, folks, for joining. We're still doing the Kubernetes this week part of the intro here. And we're almost done. I think actually that was the last like blog posty thing we have. So let's go ahead and close some of this. And we'll do our quick little Go lesson, and then we'll jump right into the Cluster API. Okay, so for our Go lesson, I put this together a few minutes ago, and I wanted to talk about function types today. Leonardo, hi from Brazil. I wish I could do like a show of hands, like who here in the Kubernetes chat has worked with function types before in Go, and yeah, just go ahead and give a +1 if you've worked with these before. I just want to see like where we are and how much I should sort of go into depth here. Anyway, while folks are answering, I'm going to start to explain what we have going on here. So the first thing we have that I want to bring attention to is this main function here, is the main entry point of the program. And what we have here is we have this other function called TGIK execute. I don't know why I exported this, but whatever, it's just a demo, so we're fine for right now. But in this TGIK execute, you can see we're passing in this thing. And what this is Justin, Decent, Mike, Sean. Looks like a lot of people like function types. So this is good because I really like to use these, and I feel like it's really easy to be intimidated by these as a software engineer because you can solve this problem in other ways. But this just allows for a lot more flexibility as you're crafting your program and mapping things together. I think the mapping is really the important part here. And we're going to look at like an example of this map here in a second after we sort of lay out the scaffolding of what we're looking at here in front of us. So yeah, all we do is we call this TGIK execute function. And in this TGIK execute function, we pass in something, which is renamed to the variable f here when we actually enter the function definition. And then we call that function and we pass in this string that says welcome to TGIK. Now, if you look at the function definition for TGIK execute, you can see that the first parameter here is of type TGIK func. TGIK func type is defined up here on line 7, and we are defining that as any function that just accepts a string as its first parameter. So this is cool because you could actually do a couple of different types of functions here. You could have like another func type, which would be like a func that accepts an int, and a string, and then that could return an error and maybe an int as well. So we can have all types of functions here, and we can define them however we want, and we can put types inside of them. and we can pass those around as any other expression in the Go programming language. So anyway, for this first one, we kept it very simple. We have a function that accepts a string and returns nothing. So here, these two functions satisfy the criteria for line number 7 here, which we have one function called simple echo that takes a string, and we have another function called exciting echo that also takes a string. Neither of them return anything. So that tells us that both of these can be implicitly passed in as a TGIK func. Meaning this TGIK execute function can accept either exciting echo or simple echo, and then we'll pass the string to it, regardless of what the function itself is. So if we run this as is, we actually get this exciting echo, welcome to TGIK, with an exclamation point at the end. And we can come in and we can say TGIK execute, and let's do a simple echo. And we will run it, and now you can see we get 2. We get one with an exclamation point and one without an exclamation point. And if you actually look at the function's implementation details, you can see that we do just that. In the simple echo, we print it out just as is, and in the second one, we print it out with an exclamation point here at the end. Okay, so why is all this important? This is important because this function doesn't change. We never have to change line 25, and in fact, this function could live in a different package or could do some sort of crazy lookup or hit some sort of API to generate the input for the different types of functions that go in here. So as a software engineer, that allows us to do things like take these different types of functions that are defined, and we can have conditional logic with it. So if not true, we can call the exciting echo one. Otherwise, we want to call the simple echo one. And this allows us to sort of have this really simple and really clean logic here without having to actually go through and change any of the implementation detail for the function. So this is sort of like a higher level meta construct that says map according to whatever logic you want. And then these functions themselves can live anywhere else in your code or maybe in somebody else's code that you don't have to deal with. A decent. What do you think about the generics proposal in Go? Well, I guess it doesn't really matter what I think because it's happening. But in general, I've been waiting for generics for quite some time. I'm not super familiar with the proposal itself. A decent, if you want to share a link to, I think it was Russ who wrote it, the proposal in the HackMD, we can pull it up and look at it a little bit later. But in general, I think it's a good idea, and at this point, I'm so ready for it that I am swallowing my strong opinions about the implementation behind the scenes. Also, just in general, generics is an extremely hard problem to solve programmatically behind the scenes. So I do want to take it with a grain of salt whenever I look at whatever implementation the Go team comes up with. I know it's not going to be easy for them, and they're probably already put a lot of more thought into it than I'm going to be able to put into it in an afternoon of reading a proposal. So yeah, if you want to share a decent, please do so. Okay, so anyway, this is using function types in Go. And you can see here, the one thing I wanted to call out was we don't actually call the function here by adding parens to the end. We just type the name of the function that we wish to call, and then we actually reference that here anonymously or dynamically with the parens down here on line 32. So anyway, function types in Go. They're handy for mapping your programs together. Now, without further ado, let's look at the Cluster API. Okay, so what we want to do is let's start off with this repo here. And this is going to be like a little bit lecture-y for the next 5 or so minutes. So if you want to go get a cup of coffee or whatever, I'm probably going to have some Diet Coke as I go through this. We're just going to sort of talk about the Cluster API and what it is. So like I have a slide on this that's like a long, long time ago in a galaxy far, far away. Like folks at Google and myself got together and started this Cluster API project, and now it's totally turned into a thing. But basically what you need to know about the Cluster API is this really complicated diagram. I'm going to redraw that in a very simple way here to maybe give folks a better understanding of what we're doing here. So here's a doc camera. We have grid paper here. So basically all we're doing now is we're defining 2 things, one of which is a cluster. And then underneath a cluster, we have multiple types of machines, right? And these are API types in Kubernetes. And because they're API types, we've decided to come together and write an abstraction as a community that's meaningful to all cloud providers. In other words, this specific machine might represent an instance in Amazon's EC2 cloud, or it could represent a virtual machine in Microsoft's Azure cloud. But ultimately, it's still going to be called a machine, and we're still going to sort of package the information up in the same way. And Nadir says, yes, that diagram's out of date, which is why I'm kind of drawing my own here. And then we have this concept of in number of machines. So, we could have and effectively attach as many machines as we wanted to this higher level cluster object. And then this cluster object actually represents a Kubernetes cluster. And we're going to go and we're actually going to look at the fields in each of these machine types behind the scenes. Now, I think what's important to know is that these definitions ultimately can, 1, exist in the form of YAML, and 2, end up in some database somewhere. That database could be etcd, that database could be another etcd server. I mean, in theory, that database could be any old thing you want. It could be an S3 in the form of YAML or JSON if you wanted. But that is how we would represent these cluster objects. After we have this in place, we would then have these other things called controllers or operators that we've talked a lot about that would sort of like exist over here. So we're just going to call this an operator. We'll say oper for short. And all that that's going to do is it's going to sort of do this reconciliation, negotiation, and update loop between wherever that information is stored. And this operator would then actually go in all of its wonderful greatness and sprinkle all of this magic out into the cloud and actually make whatever you defined here and here happen in the cloud. So the whole thing would exist as I create a new machine, YAML file, I update that, it gets saved in a database, the operator sees this new YAML file, and then it goes in and takes some sort of action in the cloud. The whole point of this whole setup is so that we can not only install Kubernetes clusters, but so that we can actually go and mutate them after the fact as well. In other words, if you wanted to create or change or delete or modify this machine, you no longer have to SSH into it or actually go do anything manual, but you would rather have to go and just change some sort of record in Kubernetes somewhere, and this operator should take care of the rest. So this is a reflection of a lot of the work that we put into COPS, a lot of the work that we put into Kubicorn, and this whole thing is sort of made possible by a kubeadmin allowing this part to sort of happen seamlessly and gives us a nice clean interface for us to plug into. So I guess that sort of diagram would look like, here's a virtual machine VM, and then there's a small, I'll put a K there for kubeadmin. And then what we're actually doing with the operator is we're actually kind of going over here and we're running kubeadmin on one of these virtual machines for us, and it's sort of managing that and updating the state updating the status as needed. Duffy, let's see what Duffy has to say. I am super excited that Cluster API is moving from an aggregated API to a controller and CRD model. Yes, so Duffy brings up a good point. If you've been following along in open source, and the reason I specifically sort of explained this the way I did, right now, we're actually creating our own etcd server with the cluster AWS stuff that we're looking at today. And the reason we have this own etcd instance is because we're doing what Duffy said, which is we're running an aggregated API server in Kubernetes. All you really need to know about that is that it's going away, and it's an outdated primitive that we used for a couple of dependency reasons. And I think a lot of the folks even talked about that going away as early as next week. So for all intents and purposes for this episode, it's safe to think of what we're doing as a controller CRD model or operator CRD model, even though we're actually creating a new etcd instance and doing an aggregated API server approach to solving this. And I guess that's a natural segue to a lot of the code that we're going to be looking at today is relatively new. And I'm kind of intentionally and a little bit mischievously pushing a lot of the engineers here at Heptio and a lot of the other engineers in open source by demoing this today just to get it up and in front of people, which of course makes me happy and I think terrifies them a little bit. So thank you to the engineers who are letting me run this code today. It means a lot to me. So anyway, that's Cluster API in a nutshell, and let's go back here, and I think my diagram was maybe, I don't know, probably just as confusing. But either way, this repository, kubernetes.sigs/cluster API, is sort of a really great example of a bad name in my mind. It does define an API. If you actually go and you drill down into I think it's PKG, APIs, cluster, v1 alpha 1, you can actually find like here's where the actual API is defined. But then there's this whole other like chunk of stuff here in the repo that really doesn't have anything to do with the API at all. It is more of like a framework or some Go code to actually help you get like your own flavor of this up and running. Let's see what Chuck says. Chuck says, "Can't confirmed, terrified." Sorry, Chuck. And Suresh says, "Yeah, I agree with Duffy. Even AWS has introduced AWS Service Operator or alternative to Open Service Broker and Service Catalog to integrate other cloud capabilities." Yeah, I think the operator and the CRD pattern, I mean, that's clearly winning here, and I think we're all kind of in favor of it. I think we had to jump through a few hoops as a community to get the software where it needed to be before we could adopt it again. And that push already went into this repository. It's now just a matter of getting it into the other one, the cluster, what is it, API provider AWS repository, which is the second one we're going to look at. We just have to go ahead and make that change without breaking what we already have running in here, which we're going to be running today. Nadir says, "Also terrified, Chuck, smiling outside, screaming inside." I mean, I'm gonna be nice. Like, I'm not gonna do anything mean or anything. I promise we're gonna have fun. But anyway, so this new repository that we're looking at is an AWS specific implementation, I think is the correct word to use there. And I'm actually gonna draw another diagram here because there's some other vernacular I wanna kind of get squared away before we move back in. So let's see, let's go back to my dot camera. I do love this dot camera. It's really nice to have. Okay, so here we have this broader level repo called Cluster API. That really, we can think of this, to use Tim St. Clair's vernacular here, we can call this the cluster framework, for lack of a better term. And this just gives us a lot of the common logic and common utilities for the cluster bits that we're going to be building later. Chuck is smiling, and Duffy says, "Y'all got this cluster API in great hands." Yeah, great hands here. Look how great I'm drawing already. Also, like, speaking of great hands, you can't even tell that my hand was broken, right? So anyway, cluster API. So underneath the cluster API, we can have different breakouts for all of the different clouds. So in this first one, the one we're going to be looking at today is going to be AWS. But as I mentioned earlier, there's a couple of other implementations out there. We know we have one for GKE, and then we could have like any other amount of implementations we wanted to here as well. But the one for AWS is exciting because we really haven't seen like this type of system come into AWS yet, this sort of declarative Kubernetes system. And furthermore, it's exciting because the whole cluster API is set up so that each cloud can also have its own subset of types of Kubernetes clusters. So underneath AWS, and we actually have a word for this. The word here is variant. We can have different types of variants underneath our AWS cluster. One example of a type of variant could be EKS. Another example could be public topology, which would be instances running in a public subnet that you could route to publicly. Another example could be maybe a private subnet, which is what we're going to be running today, that only allow instances to be accessed via a Bastion server. So you would be able to define and this goes on and on, any number of types of infrastructure behind the scenes, and then that would sort of bubble up to this broader level AWS implementation that then shares a bunch of logic and a bunch of API definitions with this like master level cluster API bit that we're talking about here. So this is just a logical way for engineers to start to structure their code so that we can keep a lot of the same logic that comes in up here at the cluster API trickled in all the way down here at all of these different variant levels as well. If you're an object-oriented programmer, this is just classic inheritance pattern, just re-implemented in the form of Go and Kubernetes scripting, or I guess I should say software. I got in trouble for using the scripting word once. Anyway, that's how the cluster API is structured, and if we go back to our repo here, we are now looking at the AWS implementation of the cluster API that we just looked at a moment ago. Okay, so that's how everything fits together. Now let's actually look at running this thing and creating a cluster in Amazon. So to start off, let's look at my Amazon console, and let's just validate that we are in fact sort of like starting at scratch here, or as close to scratch as we can get it. I like to keep my US West 2 as empty as possible. This is sort of like my magical region that I always do demos in. And the first thing I do is I sort of check this resource overview here. And this looks good. I know I have 3 security groups that I keep for like my own personal reasons, a handful of snapshots in case I ever need to get back to something that I've worked on for other projects, and then 0 running instances is like the big one I want to check for. So we know we don't have any instances, we know we don't have any elastic IPs or load balancers, and we know we expect 3 security groups. Yes, these all look like the security groups I want, and let's go check our VPC. We should have 1, which is my default VPC. Yeah, okay, so for all intensive purposes, this is a fairly empty region, meaning we don't have any infrastructure deployed here, or at least any infrastructure that's relevant to the Cluster API that we're going to be talking about today. So if you go back to the hackmd, and then this Cluster API and Cluster API bits this is the broader level Cluster API, this is the AWS implementation, which is exciting. Sean Smith says so many public keys. Yes, I have a lot of public keys. It's kind of a personal reason. I take security very seriously, and I have small scripts that help me switch public keys often. But yeah, I do have a lot of public keys, don't tell anybody. Anyway, if you go here, I lost my train of thought. Where was I? Oh, here's the go-to draft designs. If you go here, we can pull up the AWS Cluster API repo, and we want to go right into this docs directory here. So our friends at the AWS Cluster API working group have been working diligently on this getting started, and this is like, I can just see, feel Chuck and everyone cringing right now. This is the Cluster API provider AWS quick and dirty getting started guide that I was able to get up and running earlier today that we're going to get up and running right now. So to start off, let's look at what this thing requires, and let's talk a little bit about why it requires what it does. So the first thing is we need a Unix-based operating system. If you need to know why that is, feel free to ping me afterwards, because we clearly need to go out and get a beer and talk about that face-to-face. A set of AWS credentials sufficient to bootstrap the cluster. C, bootstrapping AWS identity and access management with CloudFormation. So I do not have, actually, let's see if I can do this. How do I want to do this? I'm not going to show you all my my bash profile here, but if you do look at my bash profile, it's a beautifully written bash profile, and I have a lot of these export commands defined in there that say things like AWS region, and that is set to US West 2. In fact, if let's see if I can do this. I gotta make sure I don't fat finger this commander. I'm gonna show the world all of my secrets. grep -i region. This should work. Yeah, okay, so you can see that I have a lot of environmental variables defined here, one of which is AWS region, but I also have some API secrets defined in my bash profile as well. And if we go back to our documentation here, that satisfies this second requirement here, a set of AWS credentials. It says an AWS IAM role to give the cluster API control plane. More on that a little bit later. We need MiniCube. And this is a really interesting dependency here. And I'm going to spend a little bit of time talking about why we have this dependency, and I might even draw another diagram, unsure yet. But we had a proposal come out of, and if anybody can find this and drop it in the hackmd, that would be handy. I think it was Jessica Chen at Google wrote a proposal that came through SIG Cluster Lifecycle, the Cluster API folks, that basically said, in order for us to bootstrap a Kubernetes cluster, we think it's a good idea to create this sort of ephemeral bootstrap cluster first that can run either on your local system or somewhere else. Josh says AWS secret access key. No, not going to grep for AWS secret access key. Sorry, Josh. But we would have this ephemeral bootstrap cluster that we could then use to actually deploy controllers that would then create a cluster somewhere else. So I am going to draw a diagram here because I feel like this is important to make sure we get the language right here. So last diagram, I promise, folks. So here is your local workstation. And then, I'm going to draw like a little terminal there. That's your terminal sign for your local workstation. And on your local workstation, you ultimately want to end up creating resources down here. In today's example, it's going to be AWS. So what we want to do in order to make this happen is we are first going to, sort of step one here, is we're going to launch MiniCube. After MiniCube is up and running, we're then going to deploy resources to MiniCube. After those resources are then up and running in MiniCube, those resources can then go and actually create things in Amazon behind the scenes. And that's where we get a list of these, Amazon resources down here. And this could be everything from a load balancer. Let's say we have some security groups. And then maybe the granddaddy of them all, the VPC here. And these components are interesting because after this sort of forms a Kubernetes cluster, we then sort of redeploy these components down here onto this cluster after we've created it, and we can then nuke this ephemeral bootstrap cluster along the way. And what this does is it gives us sort of a launching ground here to deploy these small bits and reuse them not only as running in controllers here, but also as running as controllers here as well. So that's why we have this dependency on MiniCube. And it's interesting because you really don't even have to use MiniCube. Really all we need is some sort of Kubernetes cluster that we can deploy our controllers to and just point those controllers to whatever Amazon account we want. So in theory, this could be a Raspberry Pi, it could be a Droplet in DigitalOcean, it could be any Kubernetes cluster that you like. In this example, we just have it all baked in to run MiniCube locally, and that gives us some flexibility with actually looking at these controllers as we're going to be debugging them a little bit later. So that's the MiniCube dependency and why we need it. Josh says, so are they like jobs that are being transferred? So they're not jobs, they're actually deployments. And we're going to look at the actual deployment code as we generate some YAML in a little bit. And those deployments in the first instance up here, Josh, are just going to have effectively pointed at AWS, whereas here they're going to be pointed at not truly localhost, but what would be the equivalent of localhost managing their own infrastructure. Felipe says, and so Kubernetes becomes a cloud orchestrator. Yes, exactly. We're actually using Kubernetes to create and manage other Kubernetes. We liked Kubernetes so much, we put a Kubernetes in your Kubernetes. So that's kind of what's going on here with this whole bootstrappy pattern with MiniCube. Personally, and I'm going to take my TGIK hat off, I struggle with the MiniCube implementation here. I think it provides a boundary between the user and what they're trying to do. I think we could find something a little more seamless, but this is a really great and easy way for us to start kicking the tires because we don't really have to deal with solving this problem because MiniCube already does it for us. So totally get why we started here, but I'm really excited to see what other types of Kubernetes clusters we can use here as our bootstrap cluster instead of MiniCube. Josh says, cool, it's turtles all the way down. Justin says, I have a good use for Raspberry Pis now. Rad. Okay, so let's actually get this MiniCube cluster up and running as soon as possible. So let's go back to our docs here and talk a little bit more about them. So after we have MiniCube, we of course need kubectl so we can do all the things. And then we have some optional commands here, Go and JQ and Homebrew and the AWS command line tool. Sean says, yeah, I have a Raspberry Pi Kubernetes cluster, and Justin alludes pretty nice to play around with. Yeah, so that would be a really great example is what if you just had your magic Raspberry Pi that you carried around with you that had all of the Cluster API stuff on it, and you could just sit down anywhere, hook that thing up to Wi-Fi, and then poof, you use that cluster to create a cluster. That's a really cool, fun example that I think would be handy, just having your teeny tiny Raspberry Pi that sort of spawns itself out into the cloud into these huge monolithic clusters. Let's see, we have Dig Olive. One thing that I noticed about one of the implementations is that it uses the CA key material of the MiniCube designed to join the tokens for the nodes of the new clusters. We should make sure to decouple those things from MiniCube. Yeah, so that's a really great point. Let me go back to my dock camera here. See, we're already 45 minutes in, and I've literally just been ranting for the past 45 minutes. We actually haven't even ran any code yet. I feel like that's okay, though. This is a very important subject for me, so we can really go off in the weeds here. Anyway, Dig Olive brings up a good point, which is we effectively, I wish I had a different colored pen. Let's see. I wonder if this is a different colored pen. Yeah, it kind of is. So we have two Kubernetes clusters. This is the AWS cluster. That's all of the wonderful AWS infrastructure. And this is just MiniCube running on some sort of hypervisor, in my case, VirtualBox. But the point that Dig Olive brings up is that there are going to be a subset of TLS certs and certificate information for each of these clusters. The one thing that Dig Olive is reminding us to do is to keep these things as decoupled as possible. In other words, if we are authenticating against this Kubernetes cluster with this certificate, we should probably only use that in one instance, and we should actually create a second certificate here to use in the same application just in Amazon, which is just a good security practice to keep in mind. Which is another huge win for having this Bootstrap cluster in general, is it gives us this really nice layer to make sure that we're managing security and keeping people away from these second tier pieces of security, as this tier can solve creating and managing those for us and keeping them away from all the evil humans who like to do all the malicious things. Okay, so Justin says, Sean, I just got one set up based on Scott Hanselman's blog. I'm assuming Justin's talking about his Raspberry Pi. Duffy Cooley says the cluster CA would be defined in the cluster level, right? Yes, that is. Well, it's not, I don't think we actually define the cert material explicitly, Duffy. Somebody fact check me on that, keep me honest, but I'm pretty sure that's the way it works. Sean Smith says, okay, I think Sean and Justin are talking about Raspberry Pis. You guys have fun talking about Raspberry Pis. Okay, so anyway, good point to go, Olive. Let's go back to my screen here. So I think we have all of our requirements in place on my local system. And we'll start off with the MiniCube command here in a second. But let's just go ahead and keep going through these docs to make sure we didn't skip anything. It says, okay, so you want to grab the latest Cluster Cuddle release. So I guess the interesting history here for Cluster Cuddle is we were on an open source call earlier this week, and I had noticed in the notes, Jason, which is D. Tiber here, Jason D. Tiberius, had mentioned that the Cluster AWS implementation was ready for folks to use. So of course I was like, okay, that means we're going to demo it on TGI on Friday, and here we are. So anyway, the two binaries that we released 3 days ago, so that gives you sort of an idea of how new this thing is, are the Linux and the, well not Linux, I'm sorry, it's the Cluster AWS admin and the Cluster Cuddle binaries. So one, it is called Cluster Cuddle. The people who created it explicitly named it Cluster Cuddle. It's not Cluster Control. And we did have to generate our own Cluster Cuddle for this implementation. And two, we have this handy dandy Cluster AWS Atom tool that allows us to help bootstrapping our authentication and IAM roles makes all that even easier. So Nadir says, yes, we currently generate the CA at the cluster level at creation time. Thank you, Nadir. And let's go back to our command line here. And we should have this cluster, let's see if I can find it, cluster AWS Atom. See if I can find a better pronunciation of this. Cluster awesome, I don't even know. Anyway, we can do cluster AWS Atom help. And then you can see that it's just good old Cobra commands. And we have alpha, which we can run. And then I'm assuming underneath alpha, we have a bunch of alpha commands. Yeah, bootstrap and EC2 and stuff. But basically, this whole thing is in place, and it creates some cloud formation for us that helps us bootstrap the IAM roles for our cluster. So if we actually run the command that it says so in the documentation here, which I've already run, it's this cluster AWS Atom alpha bootstrap create stack command. It runs this sort of idempotent cloud stack creation. And that actually was really fast. I just ran it. And you can see it's outputted a ton of instance profile and managed policy and role information, and then ultimately a user down here at the bottom that we're going to use to authenticate with programmatically as we move forward. And it did all this through CloudFormation, and if this was the first time I ran it, it would have taken 30 seconds, 45 seconds or so, and it would have needed all of the AWS credentials defined to actually go and create new IAM information. So whatever you authenticate with would need the permissions to then create more permissions. So Adecent says cluster raw SATM. Kind of like it. Okay. Let's go back to Google Chrome here. Okay, so we've ran that, and then we can actually go, and if we go into the EC2, actually not EC2, I want CloudFormation up here at the top. you can actually see we have this cluster API provider, and then this all matches what we just saw in my terminal. And you can see that it all is create complete. So we've created all this already. So that is done and out of the way. And if we go back to our documentation here, we can scroll past to this SSH key pair snippet. Feel free to come in and read it if you need to actually create a new key pair. As mentioned earlier, I am insanely overcautious about my SSH key pairs, so I have already done all of the SSH-y things behind the scenes that folks at home don't need to worry about. It will just magically work. But if you are doing this for your first time, there's good instructions here for you to get a new key pair and actually create that in Amazon. So scrolling down to setting up MiniCube. For folks at home who have never set up MiniCube before, there is this instructions here you can go and set up, but the TLDR, if you're running on a Mac like I am here, you're going to want to have VirtualBox installed or some other hypervisor. I think we can use Xhive as another one. I just use VirtualBox because I already had it for some other projects. And we want to run these MiniCube commands after we get the MiniCube binary into our path. So to run this, I've already ran this, but I'm just going to run it again for good measure. We're going to go in and we're going to say minikube config set, and that's it. It doesn't give us any output or say that it's config set or whatever, but we do need to set it to 1.9.4 for our aggregated API server dependencies that we talked about a little bit earlier in the episode. Nadir says, if anyone's wondering, I'm the PowerShell on Linux user. Nadir, do you really run PowerShell on Linux? Like I don't know if this is a troll or not. If you do, that's really impressive. If not, LOL. Jason says, how is that even possible? When I worked at Microsoft, I tried to run PowerShell on Linux for a day. Anyway, we can run this minikube config set bootstrapper kubeadmin command, and all this does is it tells us that we do want to bootstrap our minikube cluster with kubeadmin instead of what other minikube bootstrappy methods are available. Okay, so we've set those, and those exist. They persist. So now whenever I do a MiniCube setup, it will be with those configuration settings. So what we're going to do here is we're actually going to bypass and inject some of our own custom documentation here to give folks at home a better idea of what's actually going on. So all we're really going to do is we're going to manage the MiniCube stuff ourselves instead of letting ClusterCuddle do it, so that we can actually go and tail logs and see what's going on this intermediate or bootstrap cluster. Bob says, for what it's worth, Xhive is deprecated. Oh, interesting, Bob. I did not know that. Kind of a bummer, though. I know some good friends of mine worked on the Xhive project for a while. So anyway, what we're going to do is we're going to actually start a MiniCube cluster now. And so MiniCube is pretty handy because you can come in and you can actually run the MiniCube command, and it will do all of the creation-y Kubernetes stuff for you. So if you've never ran it before, you can actually come in and type minikube, and you can do -h, and it's just another Cobra command like all the other ones we see. And you can see we have all of these subcommands here. The one that we're going to use is start, and it just says starts local Kubernetes cluster. And because of those two config lines we defined earlier, we know we're going to get a Kubernetes cluster of type 1.9.4 bootstrapped with kubeadmin. So all I have to do now is run minikube start. And that you can already see, yeah, it's bootstrapping with a 1.9.4 cluster. Marcin says, it is, and if you are forced to use Azure, then you end up with PowerShell even on Linux because there are some things that you can't do otherwise. Marcin, that is 100% exactly why I tried to run PowerShell on Linux for a day when I was working on the Azure implementation of Kubernetes that has long since been retired. But yes, PowerShell is necessary if you are using Azure. She says, I assume that the AWS access keys are all fake ones. Oh, these ones here. I was like, what? Did I actually? I was like, did I accidentally echo my access keys out on the screen here? And yes, you can see here it says example at the end. Ashish, example key here. So it looks like they probably started out as real ones, and then were changed somehow and are now fake ones. Excuse me, still getting over that cough a little bit. Anyway, I've already exported my SSH key name to the key that I'm going to be using. And if we scroll down here to the bottom, we see that we're now on this generate YAML step. But before we do that, I want to take a look at MiniCube, and let's see what's going on in MiniCube really quick. So it's starting in the local virtual machine, and it's giving it a name. And if we actually pull up the, let's see, VirtualBox panel here, we can see that MiniCube is now running and is just starting Kubernetes for us. Leonardo says maybe use AWS Vault not to expose credentials. They're from the AWS docs. Yeah, they're all from the Amazon docs. Anyway, I see what they're saying. The Amazon docs are where those were generated from. I was talking to Chuck about this before. Sometimes it's like people say things and it's like 10 seconds ago in my world. So it's like, what are we talking about? Oh yeah, this is just from like 10 or 15 seconds ago. Anyway, so MiniCube is up and running, and the cluster cuddle command is going to be smart enough to actually look and see if the MiniCube is up and running if we pass a flag to it, and we'll just try to use an existing cube config to communicate with this MiniCube. And so we've modified the cluster cuddle command a little bit, and I've added that command here, right here, cluster cuddle command. It's the one command. This is like the big mama command we're going to be using later. That should actually get our cluster up and running. So anyway, going back here, this is now set up. And what's cool is you can actually do a MiniCube SSH, and you can see like we get some cool like terminally ASCII art here. And you can actually see if we go to Etsy Kubernetes, we're on a virtual machine now. And here is our admin.conf, which is a really, really great sign that this Kubernetes cluster has in fact been bootstrapped with MiniCube. So if we exit out of here, it should have written the MiniCube context directly to my cube config. So to validate that, I can do a kget nodes, and if it works, it should just say MiniCube. Yeah, name is equal to MiniCube. So we're good to go, and we're running version 1.9.4. And let's just go ahead and test if we do kget po, no resources found yet. So now let's formulate our cluster cuddle command, and let's talk a little bit about that. Also, I'm like losing my voice again. So here, we're going to run cluster cuddle, create cluster. We're going to just pump the verbosity all the way up to 4 right out of the gates. We're going to tell it provider equal to AWS. This is another gripe of mine for the cluster API folks. If we're going through the trouble of writing implementations that are unique to a cloud, why do we need to pass in provider equals AWS here? M is a flag that tells us where our machine's YAML is, and C is our cluster YAML, and P is our provider components YAML. And then this is this really long flag here that we just talked about that says the existing bootstrap cluster config. And then we just pass in our bootstrap config for MiniCube here along the way. So we'll get this command up and running in a second. And what this reminded me was I skipped a step. We still need to generate this YAML. And so what we want to do to generate this YAML is we want to run this command here. And I've already generated the YAML, but we're going to go ahead and just redo it for good measure anyway. So let's just only cd into this directory, and let's remove this out directory, and let's go back. And now we can paste our full command here, generate YAML.sh, and you can now go back to where we were, and we can go into out. Oh, what? Okay, there we go. Now we can go into out, and we can see that we have these 3 YAML files. Let's see what folks are saying. Duffy says +1 on. It's awesome. Cool. So yeah, so let's take a look at this cluster YAML. So remember earlier in the episode I talked about how we would be defining all these different YAML objects and then applying them. This is the actual declaration of our Kubernetes cluster that we want to create in Amazon. So if we cat out cluster.yaml, it's very simple. We give it a name, which is test1. We define this cluster network field here, and then we have services, and we give it these CIDR blocks. And it looks like this one is the, I think it's Calico default CIDR here, 192.168 with a /16. We give it the service domain cluster local, which I think the service domain is like the DNS bits for a cluster. In this case, we're doing cluster local, so we don't need DNS. And then we have this provider config here. Now the provider config is exciting because this is the part that is actually unique to Amazon. GKE is going to have its own specific type of provider config. Amazon will have its own type of provider config. And these are going to be all of the unique Amazon bits. In this case, we have an API version. We have a kind. This is for the API records that we're defining. We define a region, and we give it an SSH key name, which is Knova. So as the cluster API begins to grow and scale and mature, the whole point of provider config is for it to be its own versioned API. So you could have a provider config with a nested value of a certain API version, which is defined here and here. So we'll be able to plug in different APIs here for different reasons. And that's how we as a group have decided to solve the abstraction as a whole for creating a unified cluster object while still being able to define bits that are specific to your cloud. Duffy says, oh, the URL doesn't parse +1 on github.com/99designs AWS vault managed to URL to fix. Okay, Duffy, I have no idea what you're saying. Sean, looks like it worked for him. So whatever you're doing, looks like it worked for Sean. Anyway, coming back here, that's cluster. Let's now look at machines.yaml. So here, I think we really only need to focus on this part. So here we have a set of items, which this is a Kubernetes level construct that allow you to define like a set of resources. And here we have an API version, which is cadence.io.v1 alpha1. Kind is equal to machine. So this is like the actual API part of the cluster API. And this actually represents a single machine in EC2. And here you can see that we have a generate name and we have some labels that we can use for arbitrary reasons downstream. And then we have like our very familiar spec for a machine. And in here, you notice we have versions, and underneath versions, we have kubelet and control plane. So this is the actual version of the kubelet systemd unit that we want to run, and this is the actual version of all of the Kubernetes control plane components we want to run. And then we see the provider config, as we saw in cluster, that actually defines this specific machine type information. So here we give it a key name as well. We tell it we want to use the IAM instance profile that we generated earlier, and we want to tell it that it's a T2 medium. And the whole point of this is for it to be declarative so that you would be able to come in and change this T2 medium to T2 large, either yourself or from like an autoscaler's perspective or some other piece of software. And then the controller would go and reconcile that moving forward. So those are our machines.yaml. And last but not least, somebody asked about this earlier. We have deployments, and that's this provider component stuff here. I hope there's not real secrets in here. I hope those aren't my real secrets, are they? I hope they're not. That would be really annoying if you guys just catted my AWS secrets and put them out on TGIK. Anyway, we have these deployment here, and you can go through and you can deploy various parts of the provider components here for generating your cluster. Anyway, I'm going to clear that before anything else. Chuck says, I need to drop, but good luck with the rest of the demo. Thanks for giving Cluster API provider AWS a spin. So Chuck, like, we're going to cat your creds out on screen, and then we're just going to mic drop. Thanks, Chuck. So anyway, let's go ahead and let's run our cluster cuddle create command. Let's see. Let's go back here, and let's go back to our docs and grab this create command here. So we'll do this, and we won't run the command because we still have to get our MiniCube config. So let's go up on this, and let's do cluster cuddle, create cluster. Yeah, I know. Jason, if you have access to AWS, can you nuke those creds in about 5 minutes when I get done? That would be helpful, thanks. So anyway, yeah, trying to think of what we want to do here. Okay, so yeah, we're going to run this cluster cuddle command. We want to run our help again so I can get the name of this really long flag, which is this one here, this existing bootstrap cluster kubeconfig string, and we're going to append that to the end of this command here. And all we're going to do is set that equal to users/nova/ just my default cube /config. Okay, so this should do a cluster cuddle create. What did this say for us? please provide YAML file for provider component. Am I in the right directory? I should be. Why is this not running? Please provide YAML file for provider component definition. Did the /p not make it in? Or the -p? No, it did not. Okay, so we want to do -p, cluster, cuddle, example, AWS out, provider, components, and then this last command here. Okay, so that should do it. So what's happening now, if we go and we actually look at our MiniCube cluster, let me zoom in on this thing here. We should be able to go back to our repository here. We don't want Heptio TGIK. We want github.com/Kubernetes SIGs / the cluster API provider AWS. And we should be able to do a kgit PO. And this is running in MiniCube, mind you. And you can see that what Cluster Cuddle is doing is it's actually deploying the aggregated API server and a unique etcd instance into MiniCube that we're later going to deploy these resources to that will then create infrastructure in Amazon for us. So let's actually do a watch on this. As that is running, we're waiting for, okay, it is up and running. We're waiting for these controllers to come up so we can actually grab some logs here and see what's going on. So what we have here is our controller logs. So let's do klogs, cluster API controllers. We'll follow them. It's going to yell at us and tell us we need to define a container. So we're going to let's go ahead and do the cluster controller, and then we can look at the machine controller as well. So as we do that, we're going to do -c for container, the cluster controller, and we can actually go and see, and please don't let there be secrets in this log as well. We can actually go and see this cluster controller taking action against the AWS API. And if we actually go into the AWS console here, we can go to EC2. I think I saw something in the logs about a NAT gateway, so let's go to our NAT gateways here. Where are NAT gateways? Am I missing it? Here we go, NAT gateways. Okay, so test 1 NAT is pending. So if we go back to our logs, we can see that, yes, we're creating this NAT gateway here, which is what we just saw in the Amazon console. So this controller is actually going and setting up the cluster level infrastructure. And I bet if we go in and we can do AWS cluster controller, it changes this to AWS machine controller, we can actually go and see that we have a whole separate controller that's actually reconciling machines for us. Jason, I know I'm picking on you, Jason. There are no secrets in the logs here, which is good to know. Okay, so this is the machine controller that's actually going and creating machines for us in Amazon. So the whole pattern here is we have this MiniCube cluster that's creating this new cluster from scratch in Amazon for us. So if we go to EC2, we can actually see that we should have some instances coming up any moment now. Let's check our logs and see what's going on here. Unable to create machine, AWS control plane, requeue in 1 minute. Network not ready. So this is our reconciler in action. And I guess this is a really great example of why the reconciler pattern is so handy for things like this, because we can start to bake in things like automatic retries and reconciliation detection deltas, and we can come in and say, oh, let's really do a nice advanced audit of the systems in place and go and make sure that, our reconciler is smart enough to go and ensure whatever infrastructure we defined is actually in existence and making any changes as needed. So you can build in all kinds of cool and exciting logic here for checking over and over and over again and actually reconciling that to make it work. And it's not like this one and done, throw the ball over the fence mentality that you see with configuration tools like Puppet or Chef or Terraform, where you do a Terraform apply and then that's kind of it. And then if somebody goes and makes changes, then you're kind of SOL. The whole point of the reconciler here is to be able to monitor and adjust those changes over time as needed and retry whenever necessary in what we're seeing here. Okay, so we're still waiting for the network to come up. It's requeuing. Let's see what's going on in the cluster controller and see if we get any more information there. Error reconciling cluster object, unable to reconcile, no NAT gateways are available. So I think we're just waiting for NAT gateways is what's going on here. Those NAT gateways can be pretty pesky when it comes time to actually creating them. And the whole reason we need to create them in the first place is because we're doing this sort of private topology implementation where we're creating a private subnet, and we need to actually NAT into it, so we need that NAT gateway in place. So let's go back to our VPC and see if we can find any more information here on our NAT gateway. Okay, so it does say it's available, so I'm wondering if our controllers are just magically going to start to kind of re-kick themselves after their sleep of, I think it was 1 minute is what we saw earlier, happens. So that would be really handy. I'm not going to let's see. I was going to think about deleting the pods and re-kicking it manually, but I'm just going to let the controllers do their thing so that we can demonstrate that they will actually come and create infrastructure as needed. So while we're waiting for that to come up, let's go ahead and let's create a new terminal tab. And let's get ready to actually look at our cluster in Amazon. So how we want to do that is we want to go into this repo that we've been running all of our commands in, which is github.com/kubernetes/sigs. And then we want to go into our cluster API directory here. And sort of the syntax that you need to know, and I think I already have one here. Do I have one? No, I do not. But I do have one. Okay, so afterwards, after you run the cluster_ctl create command, it's going to write this kubeconfig file in the local directory you ran cluster_ctl from, which remember we're running cluster_ctl here in this, and this is sort of hanging for these components to come up and get running in Amazon. And it'll, when it's finally done, we'll echo out this kubeconfig that will allow us to actually go and interact with the cluster in Amazon. So we have this kubeconfig, which lives in this directory on my file system, and then we also have the kubeconfig that lives in this directory. Now this one is the one that's talking to MiniCube, and this one is the one that is actually going to talk to Amazon after we get up and running, which is where the whole KTX and kube contexty thing comes into play, as we're going to be looking at different clusters. Also, it's important to note that cluster_ctl, if we didn't do the MiniCube start on our own and actually pull up these logs so we could see what was going on, the cluster_ctl command would ephemerally create a MiniCube cluster, deploy to it, and then delete it afterwards. Upon that delete, we would actually lose all the log information that we're looking at here to debug this whole system to keep it up and running. So it doesn't look like these are kicking off just yet. Let's see if I can give them a quick nudge here. Let's get PO. This is me being malicious. I'm going to nuke this pod in the hopes of re-kicking off what it needs to do and restarting the controller logic so that we don't have to wait for it to re-queue. So how we want to do that is kdelete PO, the name of the pod. Bam. And now we can do our kget PO again, grab the new pod name, and we'll actually grab our logs here as well for, let's do the cluster controller. -c cluster controller. Attempting to acquire leader lease, so this looks pretty good. And all of this code that we're actually looking at the logs for is what's running in the cluster AWS API provider repository as well. Okay, so yeah, you can see that we've been able to re-queue it manually, and it's actually coming in and making a lot of the mutations that we wanted it to and creating a lot of the infrastructure for us. So, we're still getting this error reconciling cluster object, test 1, unable to reconcile network, no NAT gateways are available in US West 2A for this subnet. Interesting. I wonder if we found a bug. Jason says, I think the cluster actuator is hitting a bug related to AZ ordering. I don't think it'll recover. Oh, interesting. So it looks like we found our first bug, which is exciting. I do love finding bugs. So yeah, we still have our NAT gateway available here, which is cool. So I wonder if we can actually, let's try to kick this off one more time and see, I'm going to nuke this. See if we can't sort of re-kick this off and redeploy it and see what happens. But either way, I just really wanted to get folks looking at this code today and understanding why we're doing what we're doing and seeing the complexities of the different controllers and operators and understanding the whole point of them moving forward. It would be really rad if I can re-kick this really quick so I can actually show you that the controllers then get deployed to the cluster in Amazon as well. So let's see if I can do this in like the next 5 or so minutes. So what we want to do is we want to do a MiniCube delete. And we want to come back here and we can clear that screen. And then we'll do a MiniCube start. And then while we're doing that, we're going to go and just manually delete a lot of our infrastructure here. So the whole point of the Cluster API declarative infrastructure is to sort of solve this problem that we're actually looking at right now, which is abandoning resources in a cloud. So in other words, we've been able to create some resources in a cloud, but we have no concept of them anywhere else. Here's a great example here. So here's an elastic IP. So we're going to go ahead and disassociate this address. And let's see, you don't have permission. Do I need to change to different role? Maybe I'm hitting some sort of permission thing now. But anyway, the whole point of Cluster API is so that we can bake a lot of this retry logic in. So once these controllers are healthy, that they'll be able to come and make sure that this type of stuff doesn't happen for us moving forward. So it's just a matter of dialing in the initial creation just right for us to get a lot of the value for having this reconciliation loops running over time. So let's see, we don't have any security groups here. Let's go check our VPC. I feel like the VPC in Amazon is always like the one thing that like if you can get rid of the VPC, you're pretty much getting rid of everything. So let's see what happens when we try to delete this. I bet it's going to yell at us because of the NAT gateway. Let's see. Maybe not. We might get it first try. That would be really rad if we did. No, it is NAT gateway. Okay, so let's go and manually delete this. Oh, it's deleting now. So we're just waiting for the NAT gateway to delete, and then we can delete our VPC again. And let's go back here to our cluster cuddle directory here and try to rerun this command. And actually, I think I know what might be the problem here. I think I'm using the wrong AMI in the cluster cuddle provisioner YAML, which I don't want to go redefine that anyway because those secrets are in there, so I don't want to pull those back up. But either way, I think this is a good stopping point for the episode. We can look a little bit more into the actual pivot from the MiniCube cluster up and running, but I just wanted to sort of explain the Cluster API, demonstrate that we're getting this thing up and running in Amazon, and give folks an opportunity to start thinking about what it would take to write machine and cluster controllers and operators to actually go and get a lot of this stuff done. And I just wanted to really poke our engineers and get the stuff up and running and see what's been going on. I'm one of the organizers in the Cluster API working group, and I don't get to spend nearly as much time writing code as I used to, so I've just been really antsy to take this for a spin. So that's where we are today. I'm going to file this bug like a good open source citizen here. Let's see, new bug report. And let's see what we got, if we can pull these logs back up. Yeah, here's our log here. So title, let's do NAT gateway error, and we'll come through and we'll see. We'll just paste this log output here. Ping me if you have any questions. Sweet. Cool, and I'm sure this is not the only TGIK we're going to do on this. I think after we get a lot of the declaration stuff up and running, it's going to be really exciting plugging in other parts of Kubernetes to the Cluster API as well. I think the one that I'm personally most excited about is hooking up an autoscaler to the Cluster API, where we are actually going and creating machine YAML files as needed programmatically. We're not actually going and doing all this stuff manually like we were doing here. Felipe says, on a similar subject, next month I'll present at VelocityConf an operator I'm working on to deploy CDN clusters. I hope to see you there. I very much will be at Velocity next month, so I would love to get together and learn more about your priority there, Felipe. That sounds really rad. And I always love a good operator, honestly. They're just fun to tinker with. So anyway, thanks for joining everybody this week. It's been fun. The Cluster API stuff is exciting. I'm really pumped for us to get this thing going and to get another release out. And I'm going to continue to push the boundaries because I am just the mischievous open source person that I happen to be here. Yeah, Sean says the autoscaler also sounds cool. So I think the autoscaler is exciting, Sean, because right now, if you look at the autoscaler code, there's a ton of implementation detail about how to actually create and manage nodes. That doesn't have to be a concern anymore because all we're going to be doing is updating a Kubernetes YAML file, or not really a YAML file, but a Kubernetes object, and that could be through a YAML file or just through any old client, so that we don't have to get into the implementation weeds anymore as an autoscaler. And you can apply that same autoscaler client logic to any type of controller you want. You could have controllers that check price. You could have controllers that check CPU. You could have controllers that do arbitrary business logic, or maybe we need to run this one cron job and create a couple of GPU instances or whatever. And this all becomes now more of a programmatic exercise instead of an actual exercise of creating nodes and dealing with like the bashy implementation detail that this whole project we're looking at today attempts to solve. I think the other exciting part of Cluster API that a lot of folks don't realize is the ability to test infrastructure afterwards. If we live in a world where everything is programmatic and we can create everything through Kubernetes native objects, it actually becomes super easy to run a test against it and then get a status back and validate that status is exactly what we wanted. So actually writing infrastructure unit tests for the first time is now possible due to thanks to programs like the one we're looking at today. So this is all really exciting stuff for me as an infrastructure engineer, and a lot of the stuff here that we're looking at is in my book, Cloud Native Infrastructure, as well. So this is all really, really great, and thanks for joining, everyone. Let's see, looks like people in the chat have things to say. Justin says bye. Josh says thank you, have a great weekend. Marco says thanks for an awesome episode. Have a great weekend, everyone. It's been a great time. Thanks for joining, and we'll see everybody next week for another exciting episode of TGIK. Thanks, everyone.